an independent analysis of European defense capabilities and strategic policy.
The contemporary aerial threat environment is defined less by the technological supremacy of single platforms and more by the economics of saturation. The proliferation of low-cost loitering munitions and disposable unmanned aerial systems has effectively inverted the traditional cost-exchange ratio of air defense. This renders the exclusive reliance on guided missile interceptors financially and logistically unsustainable. Within this systemic context, the decision by the governments of Sweden and Denmark on February 3, 2026, to jointly finance and procure the Tridon Mk2 system for deployment in Ukraine represents more than a singular aid package. It signals a broader doctrinal pivot within the Nordic defense industrial complex, a pivot toward kinetic solutions that prioritize sustainability, magazine depth, and industrial scalability over exquisite, high-cost performance. This procurement initiative, valued at approximately €226 million, highlights a shift in how small states with advanced industrial bases approach the problem of high-volume aerial threats. The architecture of the Tridon Mk2, which integrates the venerable Bofors 40mm Mark IV naval gun onto a commercial Scania 6x6 chassis, suggests a deliberate move away from bespoke military platforms toward civil-military fusion. From a systems engineering perspective, this integration addresses the critical bottleneck of production velocity. By utilizing a commercial trucking platform that is ubiquitous within the civilian logistics network, now the Swedish defense industry circumvents the long lead times associated with specialized armored vehicle production. This design choice implies that operational availability and ease of repair are currently being weighted higher in the requirements hierarchy than ballistic protection or cross-country tactical mobility. The resurgence of gun-based air defense systems reflects a necessary correction in the layered air defense architecture. For decades, the trend in Western military doctrine favored missile-based engagements, assuming that targets would be high-value aircraft or cruise missiles warranting expensive interceptors. However, the operational reality of the modern battlefield has demonstrated that the airspace is increasingly cluttered with targets that cost a fraction of a man-portable air defense system, or a short-range surface-to-air missile. The Tridon Mk2 addresses this economic asymmetry through the application of programmable ammunition. The 3P ammunition, which stands for pre-fragmented, programmable proximity, allows the 40mm gun to function as an area denial weapon rather than a precision point impact system. By dispensing a programmed cloud of tungsten fragments at a precise intercept point, the system creates a high probability of kill against small, erratic targets like quadcopters or suicide drones without requiring a direct kinetic hit. From an operational standpoint, the reliance on the Scania 6x6 chassis introduces a distinct set of tactical trade-offs that commanders must accept. Unlike tracked systems, such as the CV-90 air defense variants, a wheeled commercial truck lacks the armor protection to survive direct engagement with enemy mechanized forces or artillery barrages. This vulnerability dictates a specific employment doctrine centered on survivability through mobility. The concept of shoot and scoot becomes not just a tactic, but a structural necessity for the system's survival. The platform must leverage the road network to displace immediately after firing, relying on speed and signature management rather than hardened armor. This aligns well with the domestic infrastructure of Sweden and Finland, where dense road networks facilitate rapid redeployment. However, it may present limitations in unstructured terrain or during the mud season, where wheeled logistical vehicles struggle compared to tracked counterparts. The sensor architecture integrated into this system further illustrates the move toward distributed lethality. While the Tridon Mk2 possesses onboard fire control capable of autonomous operation, its systemic value is maximized when acting as a node within a larger integrated air defense system. The presence of the Giraffe 1X radar in the broader capability package suggests that these guns are intended to operate as distributed effectors, receiving queuing data from a centralized sensor net. This separation of sensor and shooter enhances the survivability of the expensive radar assets. The gun systems can engage targets without emitting active radar signals that would attract anti-radiation missiles. It creates a defensive mesh where the loss of a single firing unit does not degrade the situational awareness of the entire battery. There is also a significant industrial and diplomatic dimension to this procurement that reflects the evolving Nordic defense cooperation framework. The financing model, where Denmark provides the capital and Sweden provides the industrial capacity, establishes a precedent for future joint acquisitions. It effectively creates a division of labor that leverages the comparative advantages of each nation within the alliance structure. For the Swedish defense industry, particularly BAE Systems Bofors, this serves as a validation of the modular design philosophy. It proves that naval turrets can be rapidly adapted for land-based applications when the strategic imperative demands it. This modularity reduces the development cycle from years to months, and a critical capability in a security environment characterized by rapid technological adaptation. However, the capabilities of the Tridon Mk2 should not be overstated when analyzing the complete air defense spectrum. The effective range of the system, limited to approximately 12 kilometers, for aerial targets means it functions strictly as a point defense or gap filler asset. It cannot challenge high-altitude bombers launching glide bombs from standoff ranges of 50 kilometers or more. Consequently, the deployment of such systems does not remove the need for medium and long-range missile systems like the Patriot or SAM-T. Instead, it frees those high-value assets to focus on aerodynamic threats that actually warrant their cost, while the gun systems sanitize the lower airspace of saturation threats. This stratification of defense responsibility is essential for preserving the magazine depth of the more capable missile batteries. Furthermore, the dual-role capability of the 40mm caliber introduces a tactical flexibility that is particularly relevant to the geography of the Baltic region and the High North. The ability of the system to depress its gun and engage ground targets transforms it into a formidable fire support asset in the littorals and archipelagos. In a scenario involving amphibious landings or light infantry infiltration, the high rate of fire and programmable airburst capability of the Bofors gun offers a lethality against soft targets and light armor that traditional missile-based air defense units cannot replicate. This aligns with the Finnish and Swedish emphasis on total defense, on where assets are expected to perform multiple roles depending on the phase of the conflict. The strategic implication of integrating such systems into the force structure is an acknowledgement that the era of uncontested air superiority is over. It is replaced by a contested environment requiring constant, granular attrition of enemy assets. The Tridon Mk2 represents a shift toward what might be termed resilient lethality. where the system is affordable enough to be deployed in numbers and robust enough to sustain operations without a delicate logistical tail. It challenges the prevailing orthodoxy that newer and more complex is always better, arguing instead that mature, proven kinetic technologies, when paired with modern software and sensors, offer the most pragmatic solution to the drone saturation problem.